Okay, so we're really happy that you're all here with us today. And I'd like to go ahead and introduce our moderator, Janet McCabe. So Janet is the Associate Director of Policy and Implementation for the Environmental Resilience Institute at Indiana University.
Hi, everybody, and thanks so much for joining us today. I'm really pleased to actually be here in Bloomington, joining Andrea on screen to help moderate this webinar today. We are thrilled to be providing these webinars for you guys, especially for cities and towns and local government officials, and look forward to your participation in future webinars and also for your suggestions on how to make these most useful to you, including specific topics. Today we're going to be discussing flooding. This was probably the #1 or #2 topic that Andrea and I have heard from mayors and other local officials as we've gone around the state as being something that is very much on their mind that is related to the kinds of environmental changes we are seeing here in Indiana. So today we have a couple of very experienced speakers to share with you information about the flooding issue and about things that cities can and are doing to address those. I'm going to quickly introduce our two speakers, give a little bit of information about them, thank our sponsors, and then we'll get going. So after some introductory remarks, our first speaker is going to be Dr. Alan Hamlet. Dr. Hamlet is the lead author of Indiana's Past and Future Climate, a report from the Indiana Climate Change Impacts Assessment. He is an assistant professor in the Department of Civil and Environmental Engineering and Earth Sciences at the University of Notre Dame. Among many areas of expertise related to climate, Dr. Hamlet's main areas of expertise is hydrology, which is the science concerned with properties of the Earth's water, especially its movement in relation to land. So obviously very relevant expertise for today's topic. Our second substantive speaker is Donna Price. Donna is a certified floodplain manager who has worked for the city of Indianapolis for 30 years. Past positions with the city have given her experience with drainage inspection, plan review, and managing drainage and levee projects. In 1995, Donna became the drainage flood plan manager for the city of Indianapolis. We have a wide variety of people joining us today. So you'll be able to see there the participation that we have. So we're thrilled that word is getting out about this webinar series. Please feel free to tell your friends if you find this useful. I want to ask if Mayor Giesemann has joined the call. We were hoping he would have a few minutes to share a few thoughts with us about the flooding issues that they have had in Portland, Indiana, and I think we don't have him on the phone.
Yeah, and if you are on the phone, Mayor, you can unmute yourself and start speaking.
All right, well, maybe we'll get him another time. I want to thank Accelerate Indiana Municipalities, which is one of our co-sponsors for this series. And many of you probably are very familiar with AIM and the support that it provides, the voice it provides to municipal government in Indiana, with more than 460 cities and towns as members. I also want to thank the Association of Indiana Counties, which has been working since the late 1950s for the betterment of Indiana county government. We really appreciate their support of this webinar series. Lastly, just to remind everybody, the Environmental Resilience Institute here at Indiana University is committed to providing resources to cities, towns, county officials, and others who can benefit from learning from one another about environmental resilience, climate change, sustainability programs, and all kinds of resources and tools. You see on this slide several key projects that we are working on here intended to assist you. And if you have any questions about our tools, please go to our website and check those out. I want to do a special shout out for the 2019 Resilience Cohort Project, where we will be providing along with the IU Office of Sustainability, technical assistance and extern capacity, trained extern capacity for cities interested in completing a greenhouse gas inventory during 2019. That's a very exciting project. We already have several cities that are eager to go forward with this and would like to add your city to that list if you are interested.
And it looks like Mayor Giesman has joined us today. Are you there, Mayor? Okay, well, maybe we'll get him later in the call.
Okay. All right, with that, I think we're ready to go to Dr. Alan Hunt. So Alan, we'll ask you, Hamlet, I'm sorry, we'll ask you to share your screen and take it away.
Okay. I will go here. All right, I think we're up. So thanks very much for inviting me. I'm going to speak today on the effects of climate change on flooding in Indiana and specifically to address the increasing risks that we see in a non-stationary environment, both in the historical context and also looking forward multiple decades towards the end of the 21st century. So as we move forward in time, there are three very important obstacles to sustainable and resilient human systems, and particularly in urban environments. So we face the challenges of aging and inadequate infrastructure. Many of our sewer systems, for example, date from the 19th century and are completely inadequate, even in their original form, but are very old and kind of falling apart. We have rising human populations, particularly in urban settings, and this is true throughout the world. We currently have about 50% of the world's population is living in cities, and over the next 50 years or so, those projections suggest we may have as much as 70% of the growing population living in cities. And third, as has already been alluded to, is that climate change is changing the statistics both of precipitation, which affects urban stormwater management and other important impacts throughout the Midwest and Indiana. And secondly, we also expect to see increasing river flooding, as I will show you in just a moment. So here are some projected changes for the Midwest. So these are at a larger scale than just Indiana, but these look very similar to what we see also in the Indiana Climate Change Impacts Assessment. So in the top row here, we see precipitation changes in percent by month. And so along the x-axis here, this is from October to September, the traditional water year. And let's look way out here in the 2080s. So we made simulations using global climate models, and for the 2020s, the 2050s, and the 2080s. So let's look at the 2080s first. What we see is a strong increase in precipitation of about 25 or 30%. So this red line is showing the impacts for the highest emission scenario called RCP 8.5. And then the green trace is for RCP 4.5, which is a sort of middle of the road scenario. All right, so we have two different levels of greenhouse gas accumulation, but all of them are showing strong increases in precipitation in the winter and the spring. Whereas in the summer months over here, we see small declines and considerably more uncertainty. Particularly in June and July here, we see about half the models showing wetter conditions, half showing drier conditions. So this suggests that in summer months, we may see things that vary quite a bit from decade to decade. We may see extremely wet conditions and extremely dry conditions, both of those in the future. Whereas for the winter and spring, we see a really strong signal. Almost all the climate models say that it's going to get wetter. So if we look back at the 2020s, we essentially see the same pattern, but it basically strengthens through time from the 2020s to the 2080s. For temperature change, once again, we see extremely strong changes here. particularly in the Midwest. The Midwest is often assumed not to have big climate change impacts, but this is actually not the case. We see impacts in the Midwest that are more than 2 degrees C higher than the equivalent numbers for the globe. So the Midwest is actually something of a hotspot in terms of temperature impacts. The largest impacts over the Midwest as a whole are in the summertime, and also there's some large effects in the middle of the winter. And for Indiana, this signal is a bit stronger in the summer than it is in the winter. And again, some of these scenarios, the highest are on the order of 10 degrees Celsius warmer on average. So that's 18 degrees Fahrenheit warmer on average. Those are gigantic numbers and are a really important impact pathway. In particular, we expect to have less snow in the future and more rain falling in the wintertime. And as we'll see, this can have profound effects on flooding that occurs in the wintertime. All right, so we expect to see wetter in winter and spring, drier and mixed regime in summer, could be wetter and drier at different times, and very strong increases in temperature, particularly towards the end of the 21st century. So in addition to these future projections, and I'll be showing you some projections of river flooding in just a moment associated with those projections, we also see a lot of evidence from the historical record that the probability distributions of both precipitation and river flooding are changing. Just to give a few quick examples of this, this is a picture of my son and one of our neighbors canoeing on our park after a 1,000-year rainfall event in South Bend, which occurred in middle of August in 2016. So we received about 8 inches of precipitation over the city in about 24 hours, and that corresponds roughly to the 1,000-year event. So there was extensive groundwater flooding and damage, particularly to finished basements in South Bend. And you can see that the groundwater table here in the park is very, very high. And so this persisted for a number of days at this level, actually. In February of 21st of 2018, we had an extreme river flood in the St. Joseph River. At the beginning of this storm, we had about 18 inches of snow on the ground in some places in the basin. A warm, wet storm came in, basically an atmospheric river coming up from the Gulf of Mexico. It first melted all the snow and got the soil nice and soaking wet, and then we had about 5 additional inches of rain over 3 days. This resulted, by the numbers, in a 2,500-year flooding event. So here I'm showing just north of downtown South Bend here. But the river stage was incredibly high. And just to put this in context, so here are the observed peak flows from the USGS records. So that's basically the blue trace here. Here we've fitted a probability distribution in orange. So you can see the fit is quite good. And here is the 2018 event. So this is stream flow, peak stream flow on the y-axis, and probability of exceedance on the x-axis. So you can see that this event was so far off the chart, it doesn't really even look like it belongs to this probability distribution. Now, again, we can't really ascribe this single event to climate change, but certainly suggests that the statistics are dramatically changing. I couldn't resist showing this picture of my basement. This was in the February event. So when the river was so high, all of the sewers were trying to back up, and I have a ball valve on my floor here, which is, you can sort of see it right here. It's shut, so all the groundwater is coming in through the cracks in my basement, and because it can't get out through the floor drain, it basically filled up to knee level. And so getting a pump big enough to take care of this actually took some doing. And these impacts, again, were quite widespread throughout the city. Lastly, if we look at more moderate events, we also see a strong signal. So observed changes in peak annual flows, again, in the St. Joseph River at Niles. If we segregate the record of these peak flows, so these are the largest flows each year, so-called annual extrema or annual peak flows, and they start in around 1930. So if we take the pre-75 data and the post-75 data and look and see if the mean is statistically different, it's very strongly different. So with 99% confidence about, we can say that the mean post-75 is higher than what we see in the early part of the record. And so this is quite a significant change. Just, not only do we see more, so look at the number of events above 15,000 CFS, for example. In the early part of the record, we see 2, and then in the latter part of the record, 1, 2, 3, 4, 5, 6, 7, 8, 9. So clearly some large changes going on in the probability distributions. All right, and so this shows the cumulative deviation from the mean, which I won't describe in detail. It just shows that we have a preponderance of above average conditions here and below average conditions here. All right, so given the observed changes that we see in the historical record and the projections for the future, when we put those two together, it's evident that there are new paradigms which are needed for the management of natural resources and the design of infrastructure in what is clearly a highly non-stationary environment. So Milley et al. Put this well. The title of their paper was "Stationarity is Dead, Whither Water Management?" And their point was that this practice of looking backward at the historical record, while it has served us well in the past, is now not serving us, because we cannot plan for conditions in the historical record which are going to be quite different in the future. We need to plan for a changing future. So one of the most important elements of this, and something that my lab has devoted a lot of time to, is quantifying the future extremes. If we can quantify these extremes, then planners and engineers can use this information to design infrastructure or policies that cope with these changing conditions. So one of the ways that we do this is we use output from global climate models. And these are the tools that we use to project, for example, the temperature and precipitation changes that I showed you at the beginning of the talk. We run these temperature and precipitation changes then through what are called hydrologic models. You can think of these as a translator between climate and water information. So for example, using these models, we can predict the peak stream flow in rivers. So similar to what we do with historical records, we take the simulations of the future, we fit probability distributions, and then we can estimate things. For example, we can estimate the changing 100-year flood in the future or other statistics of interest. So this is a case study that we have worked on where we examined 20 watersheds throughout the Midwest, which are shown here. I'm going to focus on several of these in Indiana. So 19 here, this is the Wabash River at Mount Carmel. And then 18, this is the Wabash River at Lafayette. So I'm going to focus primarily on those two rivers. All right, so we chose these basins because they show a wide range of hydrologic characteristics, and we want to see how these projected temperature and precipitation changes that I showed you at the beginning of the talk ultimately affect flooding. All right, so here are the 20 watersheds. Again, 18 and 19 are in the Wabash here. So what we see typically is there are kind of two classes of watersheds. One, which is fairly nicely characterized by the Wabash results. So because we see wetter and warmer conditions in the winter and spring, we see more precipitation as rain. We see increased runoff in the winter and spring. But you'll notice that you'll notice that this is being caused by having a lot of more rain as opposed to snow. So again, we're seeing increased annual flow. And at the time of flooding, which is often, can be actually any time in here in the historical record, we're typically seeing increases in flooding. So there are a number of watersheds throughout the basin, throughout the Midwest basin that look like this. So many of the watersheds show increasing flood risk we would expect based on these monthly numbers. Now, that said, there are another group where we often see decreasing flood risk. And so What's happening here is that these basins typically flood in the springtime due to very heavy snow accumulation. These are mostly northern basins. And so as the climate warms, even though we have increasing precipitation, it gets so warm that we don't have as much snow, and therefore the spring peak flooding actually goes down in these watersheds. But in Indiana, it's mostly the previous case where we have increasing risk in the winter and the spring. All right, so we've summarized all of these basins by calculating the 100-year flood. And so what you see here, there are the two emission scenarios. The high one, RCP 8.5, so that's the most extreme, and then RCP 4.5 are shown in the green, sort of olive colors here. And this is what's showing here is a change in the 100-year peak flow in percent. And each of these, so looking here at the Wabash at Mount Carmel, just as an example, each of these sort of salmon-colored dots is a single climate model, and then the average of all those climate models is shown in the red dot. So in this case, we're seeing perhaps a 35% increase in the 100-year flood, and this is for the 2080s. So you can see that the Wabash is kind of a poster child for increasing flooding in the region. We see a lot of basins, are showing increases maybe from 10 to 15%, but the Wabash is much, much higher. All right, we didn't in that study look at the St. Joseph River, but we did it afterwards because there were a number of people who are interested in this. Again, the St. Joseph is quite sensitive. We see on the order of a 45% increase in the 100-year flood by the 2080s for the 8.5, RCP 8.5 emission scenarios. All right, so focusing in on the Wabash now, just to give a concrete example of how these risks can be interpreted and used in planning. We'll estimate several key quantities. So let's imagine, for example, that we have designed some infrastructure to withstand the 100-year flood. And let's say that we have a design lifespan of 30 years. So this is the time frame of someone's mortgage. If we design to that standard, the likelihood that there will be a failure based on a stationary analysis would be about 26%. In other words, over 30 years, there's a 26% chance that we will see a flow above the 100-year level. So that's actually pretty high, isn't it? Even for the length of someone's mortgage, that's a pretty high number. So insurance companies are very well aware of these kinds of risks. All right, but if we consider the stationary case, where we, again, design for the historical 100-year flood, now we see this curve. So again, for the same design lifespan of 30 years, we now see almost double the risk due to these non-stationary conditions going through time. So this calls attention to the challenges that we face. We have problems enough with flooding based on extreme events that we have seen so far, but they are projected to increase dramatically. And if we look at longer lifespans of infrastructure, and many of our critical infrastructure in cities has a very long lifespan, these risks are even more extreme. In the future, for example, if we design to the old 100-year flood, we might see nearly 100% risk of failure for a 70-year design lifespan. So these impacts, I hope, convinced you have major management implications as we go forward in a non-stationary environment. And some of the important impact pathways that we need to consider include urban stormwater management. We have seen not only in Indiana cities, but also throughout the Midwest and in southern Canada, extreme events related to urban stormwater management. For example, in Toronto in 2013, they experienced the single largest natural disaster in Ontario's history in a one-day thunderstorm that cost $900 million. So these are the kind of impacts that we're talking about. They are non-trivial. They are extremely damaging. So we expect, as I have showed you, to see in many cases increased river flooding and the need to revise flood control infrastructure and operating policies relating to, for example, dams and levees. Dam safety is a concern. Just as we saw in North Carolina, with the increased hurricane risks that they had, there were a lot of concerns about dam safety there. Transportation impacts are very important. And so if we see extreme precipitation like what we saw in South Bend, this can cause flooding in low-lying areas, which can be life-threatening or cause serious safety issues just to moving traffic. Floodplain development policies and flood insurance. So our next talk, we're going to hear in detail about that, and emergency management procedures. And there are many ecological impacts. Perhaps one of the most important of them is nutrient impacts to the Great Lakes and Gulf of Mexico. If we see reductions in snowpack, which effectively armors the landscape in the wintertime, and we see more rain occurring in these extreme storms in winter, we are very likely to wash a lot of sediment and nutrients into our rivers, which then ultimately make their way to the Great Lakes, the Gulf of Mexico, and are causing huge problems related to hypoxia and harmful algal blooms, just to name two impact pathways. So I will stop here and we'll have time for questions later, I think. Thank you. Okay, I think I've stopped sharing.
Dr. Hamlet, in all your graphs, the orange shaded area surrounding the lines, what does that mean?
Okay, thank you. So we have each global climate model gives us a slightly different realization of the future temperature and precipitation impacts. So that shaded area represents the range of values from, in this case, 6 different climate models.
Oh, okay.
So the dark red line is the average of those 6, and then the range is shown in the lighter color.
Okay, thank you.
Thanks for clarifying that. Janet, I think you're muted. I'm not hearing you.
Okay, there we should be. Sorry about that. Getting used to clicking all these little buttons. Alan, thank you so much. I think you've done a great job of laying out for people how much more information we have about what we can expect in the future for flooding and storms. These are issues that local officials deal with all the time and prepare for all the time anyway, but we're going to be needing to do that more. So, one question that people might reasonably have is, okay, what should we be thinking about doing? How do we take this information and turn it into appropriate policy, budgetary decisions, infrastructure decisions, and that sort of thing, which is what local government does every day. So we're going to turn now to Donna Price from the city of Indianapolis, who's going to share her experiences over a number of years working with the city of Indianapolis to address and start anticipating some of these issues. So Donna, I'll turn it over to you and you can share your screen. Are you there, Donna?
Oh, I think you might be muted. Let me try to unmute you here. Okay, you should be all set now.
Okay.
There we go.
Yeah. How did that? Wait a minute. Okay. All right.
So we're not
Okay.
looking at your PowerPoint yet.
No, I know.
Okay. So you may need to stop sharing. Oh, there we go.
There we go.
Okay.
I knew I'd get it. Okay. Welcome, everyone, and thanks for joining in on this webinar. I'm Donna Price. I work for the City of Indianapolis. I've been doing floodplain management for a long time, and so I thought I'd talk to you a little bit about floodplain management and mapping. First of all, you know, what kind of flooding do we have, and where, and why? Well, there's riverine type of flooding and flash flooding. When you get those downpours and it's like a monsoon outside, the infrastructure can't necessarily handle it. But then there's also just localized drainage flooding. And part of that is based on how we design our infrastructure. The flooding occurs, of course, in floodplains for the riverine type of flooding, but there's also just low-lying areas and structures next to water bodies. And in reality, it can flood just about anywhere, and it does. And I've seen a lot of it. Why does it flood? Well, extreme rain events, of course. There's encroachments in the floodplain, combined sewers, obstructions, climate change, because as Alan alluded to, we have increase in frequency of rain events, increase in intensity of rain events, and duration, and the weather patterns are just changing, and we need to take that into consideration. There's also timing and peak flows, as Alan kind of talked about. You know, it can rain in Madison County, and it won't hit the White River here in Indianapolis at Notre gauge for about 3 days. So if we're getting a huge storm at the time that the White River is draining the upstream basin towards Indianapolis, then that's going to cause a lot of flooding as well. And I kind of alluded to the infrastructure limitations. A lot of people don't know this, but Indianapolis was actually constructed on a swamp, and we have a lot of basement flooding, a lot of backups. I thought I'd just show you a slide of the regulatory floodplain. So the floodplain, and I use these terms interchangeably all the time, but the floodplain really consists of the defined floodway right here and the flood fringe right here. I kind of explain it to folks that the floodway is where you have your currents and your velocities, and it conveys the flow downstream. The flood fringe is where the water kind of has to hang out until it can get conveyed within the floodway. So the encroachments in the floodway can make flooding worse downstream. Now, the state of Indiana has a much more defined floodway because FEMA would allow a 1-foot surcharge. The state does not allow, it allows anything less than 0.15. That's as much as you can increase a base flood elevation. So just a little Marion County data. We have 402 square miles, and we have 346,000 parcels. The parcels in the floodplain are about 32,000, and there are about 6,500 parcels within the floodway having the greatest risk to life and property. There's about 34,000 acres, and about 10,000 acres of that is floodway. We have about 22,000 total structures in the floodplain and 9,694 primary structures in the floodplain. So those are homes, and we kind of used our GIS, and anything 800 square feet or larger, we consider to be a home or a commercial building in the floodplain. We have about 6,000 flood insurance policies here in Marion County, and I say Marion County because zoning is countywide. But we have actually excluded cities that we do zoning permits for and floodplain development permits. So those excluded cities are Lawrence, Southport, Beech Grove, and Speedway. Yeah, where they have that little track, you know. So one of the things that we've been doing since about 1999, is we've been working on updating our floodplain maps. There are some streams where the maps are they're just not accurate. Discharges were determined, I always say coordinated discharges. You know, a bunch of engineers went to a hotel, got in a room, and said, yep, I think this is how many cubic feet per second is going to go into this channel. And so they mapped the floodplain based on that discharge. Well, those discharges are changing. So the reason for the accurate floodplain mapping is because I swear, I do not think that we had a flood until I took this position. I know I'm wrong, but we have to respond to the rising cost of flood disaster and increased flood damage. FEMA is moving towards actuarial rates for flood insurance instead of the subsidized rates for legally established non-conforming uses, or those structures that were built before the city entered the National Flood Insurance Program. We need to accurately administer county floodplain regulations, and we need to guide new development or redevelopment and try to make sure that they're going to stay safe. So what this means for us is we need to identify the flood risk so the property owners and community can reduce their damage potential and be prepared. We need to encourage developers to build so that they'll look like this and not like this. So we decided that we would determine the flood risk in areas where it wasn't shown. We would update and correct previous delineations of flood risk and convert approximate study areas to detailed study so the Department of Natural Resource jurisdiction limits and base flood elevations are already identified for property owners. One of the things that we did is the Department of Natural Resources, their jurisdiction starts at a mile square watershed. We have floodplain areas that were mapped as floodplains on flood insurance rate maps that were less than a mile square. So those were some of the areas that we concentrated on, because if somebody wanted to put an addition onto their house, we had to make sure that they were not going to build it in the floodway. So we did a lot of studies. So as I said, we've been doing these studies since 1999. We are a cooperating technical partner with FEMA, so we could use federal grants and not just city funding. And when you get the federal grants, it's 25% match and FEMA takes care of 75%. So we've studied about 183 out of 400 miles of stream so far. Actually, that number is probably going up because we're still doing some more. We obtained floodplain mapping based on redelineating the floodplains, using 2009 topo. We updated computer modeling methods, flow amounts, discharges. We reviewed the preliminary maps that FEMA published to make sure that the data was correct. We did that several times. And we also removed high ground. The maps that we adopted in 2016 were the first maps that actually used two-foot contours to delineate. Before it was like 10-foot quad maps. So I just threw this one on as correction. So what you see is the floodplain in 2001 is this blue shaded area. And then this line, after we did the study, is the new floodplain area. This is the floodway in 2001 in yellow, and then the black line is the new floodway. And why this is important is because you see all these houses right here. Well, because our ordinance, if those are substantially damaged, which means they're damaged 50% or more of the existing market value of the structure, they can't be rebuilt because they're in the floodway, and that's a high-risk area, and our ordinance does not allow new construction or substantial restoration of damage, substantial additions, substantial improvements within the floodway, because the whole idea is to try and keep people out of the floodway. And then, so this higher ground was actually removed. It was included in the floodway before, but now it's been removed. So here's another example of corrections for Wildcat Brook. This was originally a Zone 8A, which means it hadn't been studied. And so we went ahead and studied it, and so then it changed to a Zone 8E. And so the light blue shade up in here was the old floodplain, and then the heavy blue line is the floodway, and it was calculated so future developments need not pay for their own site calculations. And in this case, there was approximately 21 structures that was removed from the Zone A approximated floodplain. So, as I said, this has been decades in the making. So, in 1984, that's when we joined the National Flood Insurance Program, and the first maps were published then. In 1988, they republished the maps, and there were two maps, flood boundary and flood insurance rate map. A little bit of floodplain data is updated, but not very much. In 2001, we basically just went from a paper to digital format. So there was no additional studies done or anything like that. In 2005, we published 14 panels for where we had done some of the studies. And then in 2016, we put all of the mapping changes into the 2016 maps. And so everything was pretty much, there was better data for everything, more or less, especially since we used the 2-foot contours to help with the delineation. And we also revised the flood ordinance and adopted that. And so here's a little summary of the efforts. Keep in mind, we adopted the maps in 2016, but they actually went preliminary in 2014. FEMA money was used for 93 miles of streams, and those are shown in pink, and floodplain redelineation for many remaining streams. And then the city used money for about 90 miles of stream studies, and those are shown in green. So we're getting there. It's taken a while, but we're plugging along slowly but surely. So what happened with those? The whole goal, our whole goal here in Indianapolis is to accurately reflect the risk. So what does that mean? That means some people go into the floodplain, and some people come out of the floodplain. So we were able to remove 4,256 structures, but we added 2,900 into the floodplain. But it's reflecting the real risk, and that's what we want to do. So what? Well, the risk is more accurately shown now. So houses are elevated and they stay dry. If they're not, they may get wet. The flood elevations are more realistic, and the delineations as well. We have defined floodways now, more defined floodways, and so in DNR jurisdictions, so individuals don't have to hire engineers to make these determinations. And the base flood elevations are more accurate, so they can be elevated properly. Now, the state of Indiana requires that you build 2 feet above the base flood elevation. So there is some extra freeboard to make sure that you're high enough in case there are changes or the discharges may be a little bit higher than what was anticipated or what was approved. So, flood insurance, this is kind of our timeline. I scoped these maps out in 2004 with FEMA. It was during the public meetings for our 2005 map adoption. And a number of things caused delays. One of them was Hurricane Katrina because of the levee breaches, and FEMA decided they wanted to start looking a little bit more into levees and how to rate areas that are behind levees. And so they came up with a levee certification program. And so, of course, before we adopted any new maps, we needed to look at all of our levees in Indianapolis and determine if they could be certified and if they were providing the protection that was necessary. So we did do that. After several revisions, the preliminary maps were released for public viewing in April of 2014. We had public open houses to view the new maps in July, and then FEMA has to publish notice of the new maps in the Federal Register. In 2015, we went through the 90-day appeals period. DNR and FEMA then reviewed the appeals and made any necessary corrections. We worked very closely with DNR and FEMA on FEMA's revalidation letter for previous issued letters of map change. FEMA will issue what's called a letter of map amendment, and that is basically saying, FEMA, you made an error and my house is high enough and it's not really in the floodplain. They'll also issue letters of map revision based on fill, if fill was used to elevate structures. And then when you complete hydraulic and the hydrologic studies, they actually do a letter of map revision P, which stands for physical. So the Wildcat Creek that I showed you in a couple slides ago, that was a physical letter of map revision because it defined the floodway and the flood fringe limits better. So in October of 2015, FEMA and DNR issued what's called letter of final determination. That's when they give you a 6-month conversion time frame because you have to have the map adopted by April 19th of 2016 and the ordinance adopted, because that is the date that is going to be published on the map. So they give you that date. Now, this was particularly challenging at this point in time because we got the letter in October of 2015, and we got a new administration in January of 2016. So the mayor had to appoint new board members and things like that. So it was a real huge push to get these through. So we revised our flood ordinance, and I just put a few things in here about what we put in the ordinance. We have to adopt the effective map date in the ordinance. We also are prohibiting critical facilities in the floodplain now. So things like nursing homes, daycares, schools, and a handful of other things are not allowed in the floodplain because we need to keep those folks safe, and we want to keep our first responders safe. So from here on out, we're not putting critical facilities in the floodplain. We are requiring compensatory storage. It's 1-to-1 for the time being because we didn't require it before. So to get a 1-to-1 compensatory storage, that was a pretty good thing. And that helps to mitigate the displaced floodwaters. We're requiring bonds for elevation certificates if the structure requires an elevation certificate. And we have a stream protection corridor. The ordinance was approved by the City County Council on April 11th of 2016. And when do you think we're going to complete our mapping initiative? Well, that would be never. Why? Because rainfall events are changing, floodplains are changing, technology is improving, risks are changing. There's new variables and uncertainty, just like what Alan was talking about. We're going to see temperature changes, we're going to see climate change, we're going to see precipitation change. So we really need to be thinking about focusing on the future and adapting and utilizing the tools that are out there to protect our citizens. What are the benefits? The risks are accurately reflected. Costs to improve maps are much less expensive than the potential damage. We have improved response and recovery. We've used these maps and this new mapping to revise our flood response plan. We're doing a depth risk map so that we can see at any given time with any rainfall event what transportation routes are available, what transportation routes aren't available. We also have updated our multi-hazard mitigation plan for the future. Whatever you do in your community, it definitely has impacts on flood insurance. Having that 2 foot of freeboard above the base flood elevation makes folks' insurance policies a little cheaper. So that's very helpful. And we also can determine the need for future flood reduction projects. We've got a big one going on the north side. It's called Indy North, and once it's expensive, we've been working on it. Well, as one of my coworkers said, it's old enough to drink. We've been working on it for a long time, and it's cost us $28 million, but it's going to take a large area out of the floodplain, and hopefully that will happen in 2020 or 2021. I don't want to predict because I've been saying the wrong year for a long time now. So with that, I'm happy to answer any questions and turn it over to Andrea and Janet.
Thanks, Donna. That was great. And we had a couple of questions come in during Donna's presentation that I think you touched on towards the end, which is that your floodplain mapping project seemed to be still looking at current information as opposed to looking forward using the kind of information that Alan talked about. We also had a question come in about the kinds of things in your zoning ordinance upgrade, including green infrastructure and things other than just restrictions on property. So you touched on those a little bit. Donna, we'll work with you to see if we can maybe get a summary or a copy of the Indianapolis ordinance that we can post online and get out to people so that they can look at those things.
Sure.
So in the few minutes we have left, Andrea, can we unmute people and see if there's a question, or how do you want people to ask questions?
So we have a few questions lined up in the chat box, so we can start with those, and then we'll get through maybe one or two of those, and then we'll open it up, and you're able to unmute yourself. If you just hover your mouse over the Zoom window, you should see an option to unmute yourself. But we can start with a question from Kimberly. She says, it seems like Indy's remapping of flood is going backwards. More structure is taken out than put in. You're using recent data, but not looking at the future. Are there other ways that you could make changes to address and incorporate future information, Donna?
Well, we do take a pretty conservative approach, but we also have to follow the guidelines for the engineering that DNR and FEMA require. So we're working towards trying to figure out how to incorporate the future rainfall events into the current mapping.
Okay, great. Another question we have from Joanne is, has the city considered adopting stronger ordinances requiring existing or new structures being developed on or near the floodplains to incorporate green infrastructure stormwater management? You can only do so much through hard structure regulations. Replicating and or replacing natural hydrologic function through on-structure and on-site green infrastructure stormwater management would produce multiple value impacts.
Okay, I'm not sure exactly what the question was. Can you ask it again?
Yeah, I think she's asking if you've considered green infrastructure in flood management. And
oh, we do. Yes, we do consider green infrastructure and flood management. In fact, Department of Public Works, we as a city put green infrastructure in to help with floodplain management. Yes.
So I have a question for Alan or Donna or anybody else that's on the call who might have an answer, which is, it sounds like it was a long effort and laborious effort by Indianapolis to do this work. And we don't really have time or money for every city to go through, or county to go through this kind of process. And so I'm wondering where there are efficiencies, whether it's through state, through the DNR, whether it's through FEMA, regional watershed management organizations. Are there opportunities that people know of out there to do this more at scale, rather than each city having to take this on themselves?
So I can say a little bit about the climate change scenarios. One of the things that we often try to do is create regional scale resources that can be delivered, sort of, for example, we downscaled the global climate models over the entire Midwest. We ran the hydrology models, but when we did the Indiana assessment, we really just chopped out the grid cells that were in Indiana. So this allows you to do a multi-scale analysis. So for example, you can zoom into a city or a county or a state or whatever it is, but the resource is produced at a much larger scale to take advantage of the economy of scale involved in doing a study just once over a big area. So we think that has a lot of value. So for example, as a result of our study, we were able to share data on the White River with consultants who were working on understanding the changing flood risk. And I think those will ultimately make their way into Indianapolis's planning. But I think it's a long process of of sort of developing new procedures for estimating the risk. And one of the reasons that we don't see a lot of municipalities right now looking forward as opposed to backward is because there's not a well-defined way of characterizing these future risks that is well established in professional practice. And in many times what's wrong is that there's a perception of professional risk of doing something new and different. And so people need to become comfortable and have input into how these things are done in a way that they feel that they're professionally protected. So if you look backwards and calculate the 100-year flood, there's a manual for how you do that. And people don't feel uncomfortable with that. But when you look forward using a climate model, they become less certain about what that means.
That's a really good point. At the risk of filling up your inbox, Alan, if there are people on the call here who are interested in this information about their county or their city, is that something that can be produced?
Yeah, we actually have a lot of that from the Indiana Climate Change Impacts Assessment. So for example, we analyze the counties separately. So there are databases for your county that can be delivered. So like the pictures I showed of temperature and precipitation and so forth, those are available at the county level too, through Purdue.
Okay, that's great. I think we are a few minutes past the hour. We want to respect everybody's time. So we'll probably call it a wrap there. Feel free to shoot us questions or feedback on this presentation. Many thanks to Alan and Donna, and apologies to Mayor Giesemann. We will follow up with him and apologize. Thank you for bearing with us as we get used to all this incredible technology that can bring 50 of us from all across the state together for an hour once a month without anybody having to put CO2 in the air to drive somewhere. So next month, we will be talking about doing vulnerability assessments. We hope you'll join us for that. We'll get announcements out. And Andrea, any last comments?
No, I thank you all for joining us, and I hope you'll join us next time again on Tuesday, November 13th at noon. And you can register on our website.
All right, thanks again, everybody, and have a great rest of your day.
Thanks very much. Very
Thank
much
you.
appreciated.
Thank you.